Hello, my dear students, and welcome back. I know. Your exams are just around the corner, and I've been getting so many messages about this one chapter, problem solving. A lot of you are saying it's a bit of a headache, right? Well, don't you worry one bit. It's a super important topic, for sure, but trust me, we're going to make it really, really simple today. So, when you open your textbook and see all these diagrams, with the weird shapes, all the arrows going everywhere, and big words like algorithm, it's easy to get a little tense. It looks so complicated, doesn't it? But I'll tell you a little secret. The main idea behind all of this is actually something you do every single day without even realizing it. So, just relax. Your favorite tutor is here, and my only job is to make this whole thing feel like a piece of cake. We're going to crack this chapter together, and by the end, you'll be able to handle any question they throw at you. Ready? Let's do this. Okay, first things first. Before we even think about solving problems, we have to be very clear on what problem solving actually is, especially when we're talking about computers. See, it's not just about getting the right answer, it's about creating the perfect method to get that answer every single time. Just think about booking a train ticket on the IRCTC website. My goodness, what a massive problem that is to solve, isn't it? You have lakhs of people, thousands of trains, different classes, different timings. It's a giant puzzle. Computers are amazing at solving these huge problems, but only because we tell them exactly, step by step, what to do. So really, it all comes down to this simple three-part process. First, you have to properly understand the problem. What is it that you're trying to do? Second, you develop a step-by-step plan to solve it, and that plan, that's your algorithm. And finally, you write that plan in a language the computer understands, and that is your program. That's the whole game right there. All right, now for the part you need for your exams. You need a master plan, a foolproof method that works every time. So let's look at the 4 simple steps that you need to follow to solve any problem perfectly and get full marks. And here they are. It's so simple. Step 1. Analyze the problem. Really figure out what is being asked. Step 2. Develop an algorithm. Create your logical recipe. Step 3. Coding. This is where you actually write the program. And finally, step 4, and this is super important, test and debug. You have to check if your solution works and fix any mistakes or bugs. That's it. This is such an important point. You have to remember that a computer is like a very powerful but very dumb servant. It's incredibly fast, but it has no brain of its own. It will only do exactly what you tell it to do. So the success is not about the computer, it's about how good your plan is. Now let's zoom in on the most important part of this whole thing, the heart of problem solving. We're talking about the algorithm. You can think of it as the secret sauce, or maybe the recipe. It's the magic that turns a confusing problem into a clear solution. So what exactly is an algorithm? It's nothing fancy, I promise. It's just a set of step-by-step instructions. Think about making Maggie. It's the perfect example. You follow the recipe on the packet, right? Step 1, boil water. Step 2, add the noodles. Step 3, add the masala. An algorithm is exactly the same thing, just for a computer. Okay, now listen up, Bacha. This is super important. Put a star next to this in your notebook because this is a classic 3-mark question they love to ask. What are the characteristics of a good algorithm? Well, it has to be precise and unique, meaning every step is crystal clear with no confusion. It must be finite. It has to stop at some point. And it needs to take some input and produce an output. Remember these 5 points. Very, very important. So how do we actually write down these algorithms before we start coding? Well, there are 2 popular ways. On one hand, you have flowcharts. These are visual diagrams with boxes and arrows, very easy to see the logic. And on the other hand, you have something called pseudocode. Think of it like making rough notes in simple English before you write the final answer, and helps you plan out the logic. Here's a great example of a flowchart. Look how simple it is. This one is to find the square of a number. See the shapes? The ovals are always for start and end. And this rectangle here, that's for a process, like doing a calculation. The arrows just show you which way to go. Simple, right? Okay, so we have our steps, our algorithm. But how does the computer actually follow them? We call this the flow of control. It's like you're giving directions to a friend. You can tell them, go straight, or at the next crossing, turn left, or walk around the park 2 times. And you know what? In the entire world of programming, there are only 3 ways to control the flow. That's it. First is sequence, just do one thing after another, in order. Second is selection. This is where you make a choice, like an if-else condition. And third is repetition, doing something over and over again. We call this a loop. Let's take a look at selection. This flowchart checks if a number is even or odd. You see that diamond shape? That's the decision box. It asks a question. Is the remainder 0 when I divide by 2? If the answer is yes, we go down one path. If it's no, we go down another. This is how our programs can make choices. Okay, quick quiz for you. Let's test this. Using the same logic, what about the number 77? Is it even or odd? So, 77 divided by 2, does it leave a remainder? Yes, it does. So the answer to the question is no, and the flowchart would go down the path that prints odd. See, you're already thinking like a computer. And next up, we have repetition, or what we call a loop. This is for when you want to do the same thing again and again. For example, if we want to find the average of 5 numbers, we use a loop. The steps inside, like reading a number and adding it, will repeat 5 times. Once the count hits 5, the loop stops and we move on. So useful. We're almost there, Botcha Party. So you've designed your algorithm. But are you sure it's correct? And more importantly, is it the best one? This final part is all about checking your work to make sure it's absolutely perfect. Just imagine you write a program to add time. You add 4 hours, 50 minutes, and 2 hours, 20 minutes. And your program says the answer is 6 hours, 70 minutes. Is that right? Of course not. We know it should be 7 hours and 10 minutes. This is called a logical error. That's why we have to test our algorithms with different values, we call it a dry run, to catch these kinds of silly mistakes. And this brings us to a very cool idea. For any one problem, there can be many different algorithms that solve it. Look at finding a prime number. All 4 of these methods will give you the right answer. But are they all equally good? No. Some are very slow, some are faster, and some are super duper fast. A big part of being a good programmer is not just finding an answer, but finding the most efficient answer. All right, time for a quick summary. For your exam, these are the 5 things you absolutely must remember. 1. Problem solving is a 4-step process. 2. An algorithm is just a step-by-step recipe. 3. Flowcharts are pictures, pseudocode is text. 4. All programs are made of sequence, selection, and repetition. And 5. Always check your work and try to find the most efficient solution. And that's it. See? Problem solving is not so scary after all, is it? If this helped clear things up for you, please do hit that like button and share it with your friends who might be struggling too. And don't forget to subscribe. Most importantly, tell me in the comments, which chapter should we conquer next? Before you go, I want to leave you with a little homework, a fun one. Now that you know how to think in steps, what's a real-world problem in your own life that you could solve with an algorithm? It could be anything. Think about it and let me know. All the very best for your exams. You're going to do great.